All right, folks, we are back. This is just a continuation of where we left off from last class. So make sure you're following along in your notes. But we're going to start with the domain and range of our functions here. So we have our f of x, and then we actually have the inverse already, which is nice. So we're going to find the domain and range. We are going to graph them, and then we're going to show that the slopes are reciprocals, kind of like we did at the end of last time. All right, so to figure out the domain, just a reminder if you forgot, you need, and that should be an equal sign, that's weird. You need to figure out where your domain is restricted, meaning figure out what numbers would give you answers that don't make sense. Okay, so your domain here is going to be anything under here has to be greater than or equal to 0 to make sense, right? You can't square root a negative. So that means that what I would do is actually solve for what values we can plug in. So if you set that equal to 0, really it should be greater than or equal to 0. So that means that x has to be greater than or equal to 6. So you can plug in 6 and get an answer, but then you can plug in anything beyond that and get an answer. Okay. Your range is any answer that you can get back to wherever you can go to. So if I plug in 6, I would get 0, and then I'd get infinitely larger answers. Okay, so that's my domain and range. The nice thing about your domain and range for the inverse is they just flip-flop. So your domain is 0 to infinity, and your range is 6 to infinity. Okay, so letter B, they asked us to graph them. We're going to graph them up there on the actual graph. What I would probably do again is just label those with different colors. The point that they give you is going to be beneficial only for letter C, so don't worry about it yet. But if you don't remember what to do to plug in for your original function, plug in some values that make sense. So like we know that it's going to go from 0 to infinity. So I would plug in, 6 to infinity. So I'd plug in 6, you can make a table if you want to. 6, maybe something else that it's going to give you an answer back. So let's do 10, because that would give me square root of 4, and then maybe I know 22 is pretty big, but we can extend it a little bit, because then you get square root of 16, which is 4. So that gives me 0, that gives me 2, and so on. Okay, so anyway, we got some points. So we have that, we have that. It's a square root function, so I can assume it's going that way. I don't really need the last point. But then for the inverse, you can again just swap your x and y values. Okay, and that I'm going to do in blue, so it's a different color. And 10, and so on. So again, that goes like that. Okay, and you can kind of show that they're inverses. Now the next thing we're going to do is actually find those slopes and show that they're reciprocals. Just a reminder that you can find the slope at the given point. So the given point again is going to be 10, 2, and then 2, 10, by taking your derivative. So just a reminder, you can take your derivative, you can then plug in the point and show that they're inverses. So let's do that. We'll find the derivative of this. So it's going to be, this is really x minus 6 to the 1/2, if that makes sense from radicals. So it'd be 1/2 x minus 6 to the negative 1/2. And then if I plug in the x value, I would get 1/2 times the square root of 10 minus 6, which is 4. So that gives me 1/4. Okay, I want to do the same thing for the inverse function. So if I take my derivative here, it's going to be 2x, because this is an equal sign, not a negative. And then we have to do f prime of 2, which gives us 4. And those are reciprocals of each other. So just a reminder that your derivative of your original should equal the reciprocal of the derivative of the inverse. Okay, just show that they're inverses of each other. So it's just another way to show that they're inverses, so you don't have to do the composition of functions. So this is actually telling you exactly that. It says let f of x be differentiable. It's a function. If it has an inverse, then your composition can't equal 0, first of all, but that your derivative equals 1 over the same thing. So this is your derivative of g of x is your inverse. So another way to write that is f inverse prime of x, but it looks really complicated, so that's why they use g prime of x. So this is the same thing as 1 over f prime of the inverse of x. Actually, let me write that with our usual notation, just so you can get used to it. So this way you don't have to find the actual inverse now. You can just say the derivative of your inverse is the same thing as 1 over your derivative of the inverse. It's like literally saying the same thing, but they're reciprocals of each other. We'll go through some examples to help it clarify. Okay, so let's go through this one together. So it's saying f of x equals 1/4 x cubed plus x minus 1. What is the value for the inverse when x equals 3? So what that's saying is, we'll pretend like this is A and this is B. We want to know what the inverse of 3 equals. Okay, so let's do that down here. Inverse of 3 equals what? So what that really means is I'm going to say, if you were to move that to both sides to undo an inverse, you can just take the function itself. So that's literally saying f of what, oops, it's question mark, equals 3. Because remember, what happens with inverses is the x and the y values flip-flop. So this is actually the same thing as when f of x equals 3, because it becomes your y value. That's just a reminder of what those are. Okay, so we're looking for where the inverse of 3 equals something, right? We want to figure out what that is. So what we can actually do is take our original function and set it equal to 3, which is, I know, weird for us, but it's saying now, to do this, I can just say 1/4 x to the third plus x minus 1 equals 3. Because remember, what the y value is for the original function is the x value for your inverse. So now if I solve that, just so you know, I'm going to make your life easier and tell you you get 2 back. So that is your answer for f inverse of 3. Okay, that's going to be super important for part B. So for part B, they're saying, what is the value of the derivative when x equals 3? So just a reminder that your derivative of your inverse, so f to the negative 1 prime, of 3 is the same thing as 1 over your derivative of your inverse of 3. You guys are going to get used to just plugging it in, which is totally fine. But what this means is, in order to figure out the derivative of the inverse of 3, I can literally take 1 and divide it by the derivative of whatever I got here, which if you look back, it's 2. Okay, so then I plug in that into your derivative function. So I actually have to find the derivative of f of x now. So f prime of x is going to equal 3/4 x squared plus 1. And I have to plug in 2 for that. So I would do 1 over 3/4 2 squared plus 1. And I get 1 over 4. Okay, which I know is kind of strange. But the other thing you can do to verify that is if you plug in 2 to your original function, you end up with the reciprocal. So that's why they're reciprocals of each other, which is interesting. So if you plug it into original, you get 4. All right, so this is the same process. I want you to try it out. I know it's tough to get used to this process because it's like a lot of notation. If it's easier for you, pretend like, because some of us are going to find this a little easier. This is the same thing as saying what is g prime of a. If you like that notation, that's the same thing. So then your answer for like this would literally be g prime of that function instead. So anytime you see the f to the -1, that's the same thing as g of x, because that's how we represent inverses sometimes. All right, so try this one out, see if you get the same answer as me. Pause the video. Alrighty, hopefully you got 6. Feel free to follow along with my work if you need a little bit of help. Just a heads up about the previous question. How I got 2 for x when I set 3 equal to the function, I realized I didn't talk about it. You can just plug it into your graphing calculator because that's not factorable, so it's much faster. For this one, it's pretty easy actually to solve because you can just square both sides and so on. So you get x equals 7. That is what you plug in for your derivative function. You get 1/6, which 1 over 1/6 is in 6. Okay, so that's your answer for that. All right, guys, this is our last question for this set of notes. So I'm going to have you again just try it out on your own, see if you get the same answer as me. If you're confused by the process, I just want to make sure I'm clear about why this works. What you're really looking for is the derivative of the inverse at the given point. So this is like x equals 2, if that helps you. So what you really have to recognize is that's the same thing as finding the derivative of the y value that corresponds to this. Because remember, if you're looking for your x value for your original function, that's the y value for your inverse and vice versa. So really you're saying if I find the derivative of the x value that corresponds with the y value for the inverse, then I have to just do 1 over that. They're reciprocals of each other. So I can explain more if you want over one of my office hours if you need help with that. But try this out, pause the video. When you're done, I'll have the answer. Okay, how many of you got 1/5? Hopefully a lot of you. Again, feel free to check my work. Again, if you're confused by any of this, it's the fact that if I'm given, I want to find the inverse derivative at a. This is like saying x equals 2 for my inverse function, which means that it would be the y value for my original function, right? So notice that this would be like 2 comma what for my inverse, because they're looking for a in my inverse function, which means it's like what comma 2 for my original function. So when you're plugging it in, you're trying to find the inverse of 2 by figuring out what x value corresponds to your original function, because this is like the y value. So that x value is 1, which then you plug into the derivative of your original function to help you find the derivative of your inverse. So you don't necessarily need to find the inverse function because this is annoying to find the inverse for, and you get 1/5. Again, feel free to join my office hours if you're struggling with this at all. Otherwise, I hope you have a great rest of your day.